Hello and welcome to part 2 of the Aussie Ideas Man. We left off where the boss asked Richard if he was stupid busy, so we'll take it from here.
I mean, you're probably stupid busy, aren't you, Richard?
Yeah. There's a lot of work to create that progress.
Yes, exactly. That's great. Well, now let's talk about the drivetrain. I mean, people who are watching this video have recently seen the monthly update where we announced the Vitesco EMR3 as our drivetrain for production.
Mm-hmm.
Can you tell me a little bit about the EMR3?
Yeah, it's an exciting unit. It includes the DC to AC inverter, the electric motor, and the gearbox, including differential, all in one unit. So
I'll start by saying the cretin at AOC had already explained this. He'd looked up Vitesco and guessed it was the EMR4, but in either case, he showed enough information to tell us this. Now, it was the cretin that was saying we'll need this podcast to tell us a lot more about it. So what I'm looking for here is that more about it. And so far, no more. So keep your ears pinned open and have a listen for what we learn about the drivetrain. They've spent 8.5 minutes waffling on about irrelevances, but now we're on about the drivetrain.
there are just two cable connections for the DC bus. There's no separate inverter. It has one coolant in port, one coolant out port. So it is liquid cooled, allowing us to maintain the performance that we need. And really, it's a very tightly integrated package that's very compact and fits, in our unique aerodynamic nose cone. So it's quite an exciting unit. It's 150 kilowatts, 300 newton meters. We are able to maintain a high level of performance that I think will generate the excitement that our drivers are looking for. And I'm just really excited with the integration that we're doing to make this part of our vehicle.
That's great.
Yeah, we. I mean, as folks know, with the PI builds, we're building that first vehicle right now, the Mercury, which is PI2. So I think by naming it Mercury, we unleashed a torrent of either astronautic theme and Greek god theme names, for the rest of the project: Artemis, Hermes, etc., Gemini. But we hope to demonstrate that, by mid-August is our target. And driving around, I think we have a very, very, very limited specification, that we've given the engineering team. So this first driving Bink is not going to be a fast vehicle or track vehicle. It will be in a few months after that, but we hope to demonstrate that very soon.
Yeah, it's
So there you go. That's, I think, about all you'll hear about what the motor will do. And Steve has switched the focus to Greek god names and different things. It is just about August now, so there's 2 weeks for them to have this thing on a track. And then you'll notice Steve says a few months after, when it can go a little bit faster. So already, what's a few months after August? A few is 8, technically. But these days, people refer to a few as maybe 3 or 4. So at the earliest, mid-November. And pretty soon they'll all be taking a month off for Christmas.
super exciting. It's fun to see all the integration work going on downstairs with the motor. Really cool. Well, let's for a minute talk about when this change started happening behind the scenes. And a lot of people are wondering, did this delay did we have to modify the CPC parts? Did this delay the suspension? What changes went about with introducing the EMR3? And is it going to further delay production, or is it actually going to potentially bring production forward?
The short answer is, we're still on track with making the first, I'd say, production intent units in 2025. So it did cause us to redesign some of the chassis and frame. Obviously, to package this motor, in-wheel motors are simpler to package, and that's one of the attractions about them,
Right.
Amongst other things. But for us, there were just a couple of factors that made, we're developing so much from scratch, right? We have this zonal architecture system. We have a mountain of software to write. We have a new carbon SMC body. And of course, new solar panels that couldn't be made before we developed the IP to make them.
Yeah.
And so we have a lot of new stuff that we're doing. And at some point, you just have to draw a line and say, look, we can only innovate so much and launch, on time. And so for us to really keep to the launch schedule, we felt just having something more mature initially would be the best for APTERA, the product, shareholders, everybody involved. At the same time, keeping a very clear idea of how in-wheel motors can be used in the all-wheel drive version moving forward. But at launch, we felt this powertrain change was a necessary step to simplify all of the remaining tasks that we had to do in order to launch on time.
Right. And
Did you get that short answer? That right there is snake oil. You clowns ought to recognize snake oil by now. He was saying they're doing this so that they're launching on time. The end of 2021 was launching on time. We're now mid-2024. They are long past launching on time, yet they still talk about it as if they're going to be on time.
to be clear, this has been, let's say locked in for a while, right? So like the crash simulations that people have seen previously, it's all been with the inboard motor. So
that's right. And you can imagine the changes, that have had to happen because of that, and the increased time and in simulations and all the iterations, to get it right, and software. Haven't done the physical testing yet in terms of crash. It's only been software simulation. But those materials are very well modeled. The specific alloys of aluminum, the properties of the carbon SMC. That's another reason to go away from the honeycomb or sandwich core composites is they're, like, mathematically speaking, when you look at a sandwich panel, you have discontinuities between each layer, and discontinuities in any endeavor, especially electrical, are difficult to model. And the beauty of SMC is, even though it doesn't have the same strength weight ratio as a high performance sandwich core composite, it can be perfectly modeled in all phases of use, even past beyond yield. And so because of that, we've been able to successfully model this vehicle in terms of, resonant frequency, different modes of vibration, and of course the crash side impact and front impact.
Right. Yeah, that's great. I mean, one of the things I'm most excited about is the supply chain availability. The EMR3 has been in almost 1 million EVs around the world. So like you were saying, launching with something that's proven that we know we can get in these vehicles is really exciting. I mean, is that exciting for you to work with something that, this is a big tier 1 supplier?
They're a great tier 1 supplier. They can provide a lot of the support that we need to be able to integrate it quickly. And you can just see that it's a top tier team of engineers that are supporting that work. And
let's just ask the question. Now, I'm going to, before the cretin visits Carlsbad, I'm going to make up a list of questions that he could ask. But right now, he could pick up the phone and ask them, how many of these motors have they got sitting waiting to go in the up to 16 prototypes that they're going to be building? They've known for something like a year, and they're easily accessed. So how many have they got? We've seen one inside a glass box, but they should have plenty more by now.
Since it's a mature product that's been in production, we have a really high confidence in its capability, its durability, reliability. So,
right, yeah, I can't wait to see PI2 driving around.
I know,
with Tesco motor. That's really exciting. Can we talk about like engineering as a whole, the process, and how you weigh trade-offs, like how you weigh all these different factors, price, availability? I mean, that must be insane.
Well, I mean, you said it, price and availability. There were and have been lots of powertrain options, including rolling our own and also including, co-developing as we were. All of them take time and money. Yeah. And there might be a really sweet unit made by some company, but maybe the NRE, the sort of upfront charge is $20 million, just for the privilege of buying it.
Right.
So those are all factors. Also, country of origin, who the partner is, how are they doing, what other examples you might find that product in. Are you going to be able to get the support? There's so many factors that come into play, in addition to cost and in addition to risk. Risk is an issue. You never can eliminate it, but you certainly want to manage it and minimize it as much as you can. And so, maturity of a particular thing is one way we can do that.
Right. Yeah.
Look back at when APTERA first proposed their machine, and it was on the basis that they wanted to make the most efficient vehicle ever. They never said that they would skimp on price and availability issues or anything else. Now they are. They've changed. They're not making the most efficient vehicle ever. They're just making excuses. And just on the side, I'm wondering why Steve is falling off his chair to the right. Chris's deodorant not working for him?
Yeah, totally. Sounds like it's an extremely complicated business.
I mean, if it were easy, I guess everybody were doing it,
Yes.
But
yeah,
it
makes sense.
Anything of value, there's always, I suppose, lots of variables at play. We have to do the best we can.
Yeah, absolutely. Well, it's really exciting that we've had kind of another option, a plan, and the ability to execute on it, and to have all that design work already completed by this point. So we're building these PI vehicles with the EMR3 right now.
Yeah, I mean, we have a fully vetted, designed, and simulated, crash-tested solution for in-wheel motors. That frame, subframe, that'll exist. That was done over a year ago.
Yeah.
But the new system that we have was really, had to be tuned for the EMR3. But that's all done. The tuning that we still have to do is, well, you have to make the first castings. And when, CoStat makes the first castings, they're going to find things that they want to change. And we're going to see things that we can't see in the CAD. We're going to say, look, the wrench or the tool fits in the CAD just fine. But when you go to do it in real life, maybe you find your hand can't articulate that way. And so there's always going to be some changes and evolution, the first several hundred vehicles.
Right.
But in terms of the core design, simulation, and strong belief that it can achieve the goals of both vehicle performance, safety, and we can be able to make it within budget, I think we're there.
Yeah, I mean, that's exciting.
Yeah.
Richard's been he's been a big part of making this happen, though,
He is.
because it's one thing for management to just have an idea and say, oh, well, we're going to use this or do this product. And someone has to tie it all in together, hardware, software, firmware, modeling, everything else. And we're so glad to have Richard back, because without him, that just wouldn't have been able to happen.
Yeah, how's that process been going? What kind of
Very
things have you had to keep working on to get all of this together?
Oh, we've been working with the electrical systems team to integrate it within the rest of our low voltage and high voltage harness designs. We've been working through procurement of the associated connectors, which can be surprisingly difficult to acquire. And then all of the software work in the vehicle control unit to interact appropriately with the motor system. So they communicate over a protocol called CAN and a controller area network, and that allows us to command specific amounts of torque from the electric drive motor in accordance with what the driver is requesting through the accelerator and brake pedals. So that's all work that is ongoing and will continue for quite some time, really. There's a lot of refinement that continues even beyond achieving basic functionality. And that's where.
Now, I know very little about the engineering side, but I recall Richard saying that there are only 2 electrical connectors to the motor. So how is there a lot of work when they are only plugging in 2 electrical connectors? And the other thing is, he's busy with the software. But when you look at the concerns of people who write in comments on sites that I'm blocked, their concerns are all about the CV joints, drive shafts, and other matters. I don't think I've read one comment that is concerned about any software integration with a tried and true motor. They're worried about the loss of efficiency through the mechanicals. Yet this is avoided by Richard.
Where it is.
I mean, there's a certain well-known electric vehicle manufacturer that you know personally, right, that you have, who give software updates over the air regularly. And, you know, the vehicle, I think, will always be going through software improvements and sent over the air. So, to Richard's point, no one really stops writing that software.
Yeah.
Either fixing bugs or improving it, making it more efficient.
Yep.
Trying to get more range or better drivability. You know, same with the solar, same with how the solar charger works and the logic when it comes on and off and that kind of thing. So this is going to be an ongoing effort.
Right.
I'll leave it at this point. I've got 10 minutes left for a part 3. But on Steve's last comment about software always having to be ongoing, that's contrary to what Chris was saying many, many months ago when he was saying, let's get the hardware done. The software can be written last and quickly. It's an easy thing to do, so we're not going to look at it. So here we have one CEO saying it can be left to the end, it's quick and easy. And then we have the other CEO saying it's going all the time, it's hard. Somebody is lying. Bye for now. Stay safe. That's all from me.